Good morning, all, and welcome back to the second part of our Tech 4.0 Stage 1. Hope you've had time to go and get a cup of tea and some refreshments. And with that, I'll pass you over to John from Virtalis, who's going to talk us through his presentation. Over to you, John.
Okay, thank you. All right, so let me just get my slides active. Okay, so hi, everyone. So I'm John Maxfield. I'm the Business Development Director at Virtalis. I'm joined today with my colleague, Paul McCall. So thank you for taking the time to join us today. We'll be discussing the topic of XR collaboration and our platform that we use to help companies on their digital transformation journey through the end-to-end product lifecycle. Before we jump in, I'd first like to give you a very brief taste of the range of projects we've worked on over the last 25 years with our clients. Let me just, okay. So hopefully, as you can see, at Virtalis, we've been supporting the industrial enterprises for over 30 years. We've been working with many organizations on the adoption of XR and Industry 4.0 technologies, as you've just seen. However, many organizations are now facing what we would class as a perfect storm of challenges, with demanding customers, disruptive competitors, together with significantly increased business and data complexity. In addition, they're facing this perennial objective of reducing operational costs alongside the more contemporary requirements for improving customer experience and business agility. To achieve all of these objectives within this perfect storm context, transformation is a business necessity these days, affecting all aspects of the value chain, including product development, manufacturing, operations. In a survey of almost 3,500 employees spanning all industries and functions, Gartner discovered that around 90% of corporate leaders view digital transformation as a top priority for their companies. In this same survey, 83% of those leaders admitted to struggling with making meaningful progress within digital transformation. Typical questions that we hear about every day from our senior executives How do we get our product to market faster and accelerate distributed hybrid workforce? What is, this is common these days with the pandemic. How can we fully engage with our supply chain and leverage these new 4.0 technologies, such as digital twins and IoT networks? And how can I keep my distributed workforce up to date and benefit from these emerging technologies such as XR and more increasingly, we keep hearing the word metaverse. Enterprise leaders are learning that actually digital transformation isn't really about transforming from one thing to another in one step, in that there's no real end state. Rather, it's an iterative cyclic process of continuous improvement, just as the product life cycle itself is. And it's a continuous process from initial concept to manufacture to operation and eventual decommissioning and recycling. The digital thread at the heart of this interactive process these days is the contextual digital twin, the single source of truth that supports concurrent engineering across the entire product lifecycle and allowing design and engineering functions to efficiently accommodate assembly, manufacturing, operational, and maintenance requirements. New technologies that can deliver this contextual digital twin through a cloud-based platform are already enabling enterprises to address the cost and time pressures faced in this modern global economy. So let's just take a quick closer look at what such a platform might look like and what core components are required to deliver these benefits. The Virtalis platform fully supports this digital transformation process by delivering a contextual digital twin right at the heart of the organization. By bringing together all of the complex product and process data from a huge range of sources across the enterprise and supply chain into one place, we create what we call a virtual BOM, or bill of material. This is delivered over a cloud platform, allowing secure access and instant collaboration to large digital twins involving complex models, virtual prototypes, processes from anywhere within the organization at any time across multiple devices, from smartphones to tablets to desktops, even to immersive devices that are common now, such as HMDs. In essence, this creates what we call I guess what you might class as an internal metaverse within that value chain of design models, virtual prototypes, digital twins, and a whole range of virtual assets, making them instantly accessible across the whole organization to support design reviews, manufacturing planning, training, standard operation procedures, and planning for maintenance tasks. Moreover, the underlying data for these virtual assets can come from any source in the organization, and a link can be maintained with that data to ensure that any changes in the source data are automatically propagated back into the cloud, so the virtual assets are always kept up to date. And this ensures that the digital twins that are hosted on the Virtalis platform always represent the most up-to-date version of the product and the associated processes throughout that product lifecycle. So I'm now going to hand over to Paul, who will provide a demonstration and a real example of how this platform supports the end-to-end lifecycle, providing instant access to advanced visualization of the continuously evolving product at all stages of the process.
Hi everybody, I'm Paul McCall. I'm Senior Solutions Engineer here at Virtalis. What I'm going to do today is walk you through one of our suite of applications for doing advanced visualization. This application will allow you to bring in huge amounts of data from a number of different sources. What we've got is a mock-up of a factory here. This mock-up actually includes data from Revit, so the building. We've got inventor data, we've got SolidWorks data, we've got FBX information, but a vast proportion of the detailed information comes from one of our clients, Vestas, and this is Creo data. It's data from their wind turbine. So what we're going to do is have a quick look at how you can utilize visualization right across your enterprise, and how that single set of data can help you in lots of different places. And to do that, we'll use this factory, we'll use our onshore wind farm, and somewhere out there in the distance, we'll use our offshore wind farm. Okay, so let's have a quick look at this scene. Okay, so here we are at our offshore wind turbine. We can see the engineer's boat's arrived. He's obviously arrived to come and service the wind turbine. This brings up an important point, that it's not just the design of the nacelle itself that we can check. We can check the design of the pylon, the way that that's mounted on the seabed. We can look at the platform, how the engineer gets on board, and we can check all of those things out using the same single data set. So what we're going to do is we're going to sort of walk up the ladder. We'll fly directly to the top and look around us here. We can see there's a complete wind farm. Now, each of these wind turbines could be in full detail if required, so every nut and bolt. And we manage that, and we're able to do that in visualization by managing what we call the LOD, so the level of detail. As we fly in here, we can see that we're not drawing nuts and bolts in the casing. And we only draw what we need to see when we need to see it. So as we get closer, we can see that these nuts and bolts are appearing because we need to see them. When you import data into our applications, every part is automatically accessible. So we can click on a part and we can pick it up. So let's go in there. So we've got the nuts, the bolts taken out. Let's remove the washers. So every part is accessible here. We can even pick up the casings, for example, drop those back. And when I say we've got every part in this scene, I can prove that by showing you the tree structure. So here on the left hand side we have an illustration of the tree structure. So when you import your different data sets into this application, the engineer wants to be able to see that all of his files are in the right structure, and we maintain all of that structure. We maintain the file structure, the file names, we maintain all of the metadata that goes with all of the parts as well. So this is fully explorable down to the even finest level. If we take a step inside, imagine the engineer was going to do a maintenance process. He can actually practice it using this same CAD data set. So now we've got a full data set in VR. We can make it as realistic as we like. We can have textures and lighting, and you can see there are some shadows, etc. here. Or we can get inside the nacelle. So we can check for access. We can check how we're going to assemble it, how we're going to build it, how we're going to maintain it in the field. We could rehearse things. So if the engineer doesn't have much experience with the commutator assembly on this turbine, he can get in there and have a look. We can get in at every step and take it apart and disassemble it and work out what we need to do in order to fix a problem. All of this is rehearsable using this data. So a full nacelle here in every detail, to the detail that you wish to use. And it could not just be a full nacelle, it could be a full wind farm. So right now, what we'll do is we'll swap back to the factory. We'll see how we get to this stage of a full data set and how we utilize that in other places. Okay, so here we are back at our factory model. As we said, we're going to walk through and see how you might come up with the design and optimize the design of any product that you're building. So you put a large amount of effort into designing your products in CAD. But now let's utilize all of that effort and that CAD data to its full value. What we want to do is make sure that CAD data is correct. So we do detailed design reviews. Now, these days, most of our clients are doing these design reviews in VR suites. So a VR suite might consist of a large scale wall. This one happens to be a rear projected system, but we have LED walls as well. On that wall, you would import your data, you would choose your data, and our software has the ability to import lots of different data types. So perhaps, I think, just over 40 different data types. Here we're importing a bit of data of a gear assembly, and that will take just a few seconds to import, and we're back in here. So in your VR suite, you'll be projecting a three-dimensional item, which we're trying to simulate in this view here. That data has just been imported from its native CAD package, but automatically and instantly, every part is accessible to you. You can access everything, no coding necessary. So all the file structure, which we can show you here, is correct. No file names in this case, but the file structure is correct. Every part that we pick is choosable in this tree structure. So we can decide from this that we have a product that's designed well and correct and should operate. Now we're going to work out how we're going to manufacture that product. So we need to do a bit of factory planning. Our applications can be linked to a discrete event package like Witness, for example, and we can visualize that data in 3D within a virtual environment. So we can link real-time discrete event simulation from Witness directly into our suite of applications. But to do that, we really need to know how big our factory is, what the layout's like. And if you don't have a CAD model of the factory like we have here, you need to capture that data. So how might you do that? Well, you could capture a factory or any sort of data by point cloud scanning it. So simulate this scan here. So here we can see the point cloud being built up by a number of scanners. And we have now a detailed scene built up from point cloud. This point cloud is actually overlaid on top of our CAD model. So we can see how accurate the point cloud is compared to the CAD data. And we can even see, if we fly through the roof here, we can see differences between what was designed in the CAD, so this roof light here, and what was actually delivered in the end, which is illustrated by this point cloud of the roof light here. So now we've got our factory, we've got a factory model, it's all laid out. We can move back into the design suite, we optimize our designs, we do our layouts, but we can now go then and work out where our machines are going to be within that factory layout. So if we drop down into the production area, just to give you, to be clear, this is the same factory, the VR suite was up there on the left, and I'm just jumping around using some preset flight points. And what we've got here now is an optimized layout of our factory. It's a fairly simplified one in this model. We can actually connect the model to a live data set. So you could, in fact, connect all of your machines in your factory to your visualization scenario and actually see what those machines are doing in real time. So we can look at that IoT data and see what's happening. But the reason for planning a factory out is so that you can optimize that layout and make sure that you're getting the best use of every square meter of your factory. We can even get down here and walk around the factory and check lines of sight. We can check flows of information, flows of data, flows of products around the factory. Then we can work out how this product is going to be built and whether the products are being built to the right quality. Here, we're now swapped over into the assembly area. We've got a turbine blade. This turbine blade data has been picked up from statistical information that's in a database somewhere on a server, and we're illustrating that in a visual way rather than something like an Excel sheet or a dashboard of some sort. And we can see instantly whether we've got areas of problems. So here we can see at this point there is a problem in the thickness of the coating on this turbine blade. It gives us a very quick visual indication and allows you to make decisions really quickly. And because we've got a factory laid out, we can actually have our turbines in place, and we can work out how that work cell might be optimized, how the installation procedure might go, and how that might be optimized. We can also, once these products are built, so we've designed it, we've worked out how the factory's going to do it, we've worked out how the engineers are going to assemble it, and we've built a product, once it's in the field, you can actually use VR to monitor what those products are doing in the field. So you could bring all of this data back in real time to a number of monitors in the virtual world. Here we're not actually linked to anything, but these could be real-time simulations of what's going on. And to illustrate how that real-time might work, if we fly up into our land-based turbine, so our onshore turbine, so we're now up at the top of the turbine. There's the factory down below us. We can walk inside. Some of the parts within this turbine are linked to IoT data. So these orbs are placed on various products I can click on, and my system will automatically go and research and connect to a database on the web and bring back real-time data. Happens to be saying there's a fault report on this product here and it's losing a bit of oil. So we know now that we have some maintenance to do. So what we've seen is not only how we might check the designs that we're creating in CAD, but how we can use that CAD in lots of different places throughout the factory. How we can optimize our factory design, how we can optimize our layout, our work cells, our production processes, how we can check our in-service usage of the product, how we can do our maintenance planning, how we can rehearse. So using the data in lots of different places right the way through the life cycle of the product. I hope you find that interesting. Thank you very much.
Okay, thanks, Paul. So as you can see, the Virtalis collaborative XR platform allows you to immerse yourself in a large, complex model at one-to-one scale, including every pipe, every cable, every nut, every bolt in full detail, and creating a live contextual digital twin as a single source of truth right at the heart of your business, while delivering effortlessly instant collaboration with anyone, anywhere within that value chain safely and securely, and also across the entire product lifecycle from design and engineering all the way through to maintenance and operations. This platform incorporates much of our learning and knowledge and expertise acquired over 30 years as global leaders and pioneers in the advanced visualization market across different sectors and markets, including 20 years of deploying solutions in shipbuilding and offshore energy industries with clients such as Subsea 7, Seaspan, Siemens, BAE, and many, many more. So that concludes our presentation for today. I hope you found it interesting, and I'm happy to take any questions if we still have time. If you want to, you can come and join us, and you want to discuss things one-to-one, come to our virtual exhibit channel. You can also contact us and follow us through social media, through LinkedIn. With that, I'll say thank you for listening. I'm happy to take some questions. I'm back to you, John.
That's brilliant. Thank you, John. And I say a picture speaks 1,000 words. I think a video speaks probably 100,000 words. So really great to see that kind of everything in motion. If you do have any questions, please feel free to drop them into the kind of Q&A. But just to start off, one from me is, what are the benefits of kind of the XR-based design reviews? And then how do people capture some of the critical design decisions that come out of that?
Yeah, well, it's an interesting question. I mean, obviously, a lot of people will be aware of the benefits of virtual prototyping and what we've talked about for many years, and the cost and time savings versus physical prototyping. But obviously, there's also the benefit of this one-to-one scale review that we showed in the video. This is not just about reviewing whether it looks right, but we can also immediately start looking at what we call the abilities, I think is the best way to put it. Manufacturability, assemblability, accessibility, maintainability, all of these abilities which you can start to assess when you've got that one-to-one level of interaction with the model. You can also, what's the beauty of having it on the cloud and being able to interact with your colleagues instantly is that we can pull together experts from across the entire organization, across the supply chain, truly delivering this idea of concurrent engineering that's been talked about for many, many years and breaking down those silos. In terms of recording decisions, within these virtual environments, we have technology, for example, in our platform that allows us to annotate models. So as you're discussing things and taking things apart, we can put annotations on things, and we can comment, we can record design decisions or discussions or even whole conversations, and we can tag people in those conversations within our organization, so they get notified if they've been, if we've been talking about, oh, well, this guy might know more. And as soon as they're notified, they can jump into that call or that conversation as well. But it's also recorded with the model as well. So when it goes back offline, the digital twin preserves all that commentation and all that, all those annotations as well. So it gives us really that rich ability to not just review, but also record those decisions as well. So hopefully that answers the question.
Yeah, that's fantastic. Thank you. Thanks on behalf of Tech 4.0. Really interesting presentation. As John says, if you want to reach out, they've got a virtual stand and on social media as well. So with that, John, thank you. Please join us in the next session, which will kick off shortly. Thanks.
Thanks very much. Thank you.
Cool. That's great. Thanks, John.